Hello everyone, welcome to my channel. I request you to see the RC3 of RC3 video, RC3 channel video, which is basically my disclaimer. Let's get started with today's topic. Today's topic is RC3 of 1 plus 1. So, quick question for you: what is 1 plus 1? Did you say 2? Let's try again. What is 1 plus 1? Confused? Okay, 1 plus 1 is 1 plus 1. Only when I say what is 1 plus 1 equivalent to, are you allowed to replace it with an expression like 2. You see, the equal valency or the equivalent to operator basically means that the count of entities on either side of the operator is the same. So without the equal valency operator, you're not allowed to replace it with 2. So now let me help you again. What is 1 plus 1 equivalent to? Are you saying 2? Let's try that again. 1 plus 1 is equal to 2, but it's also equal to 3 minus 1. It's also equal to 4 minus 2, 4 by 2, 6 by 3, etc. And you do see that each of these expressions is different. 3 minus 1 is different from 4 minus 2 is completely different from 4 by 2. In 4 by 2, I'm saying how many groups of 2 can I form with 4 items. Whereas in 4 minus 2, I'm saying you have 4 items, I take away 2 items, how many are left with you, right? So 1 plus 1 is equivalent to any expression which is equivalent to 2. Or technically, you can argue that if you have 1 plus 1 where you have one item and I give you a second one, you end up with two items. But it could also be that I gave you two items extra and then pulled away one item, so you ended up with two items. So you can argue both ways, and I will accept that 1 plus 1 equal to 2 is a valid answer. But just keep in mind that because it's an equivalence operator, there is a case to interpret all the other explanations or expressions as well. Yeah. So the topic that we, however, want to discuss in this video is, can you prove that 1 plus 1 is actually equal to 2? Yeah, so moving forward, how do you prove that 1 plus 1 is equal to 2? Whenever I've talked to people, I've got the usual explanations where they say, if I have one pencil and I get another pencil, then I get two pencils. So 1 plus 1 equals 2. Or if I have a box or a grape or whatever, and then I get a second one, I end up with two grapes. So 1 plus 1 equals 2. But there are certain confusions in this, kind of a proof, because if I take a new pencil and if I take an old pencil or a half-used pencil, that's not the same as two half-used pencils. And certainly you wouldn't trade two new pencils for two half-used pencils, right? So the valency on both sides is the same, but the two expressions are not the same. Another important point out here is that equivalence is a equal valency operator and does not mean is the same as, right? So 1 plus 1 is not the same as 2, it just has the same count as 2. So technically, 1 plus 1 equal to 2 may hold in this case, but there's a problem with proving it this way, right? So let me give you a completely different case and see if we can try to understand this better. So let's take water drops, right? So in the first case, I take one water drop, put it on the table. I take a second water drop and put it beside the first water drop. So now I've got two water drops. In the second case, I take one water drop, put it on the table, and I put the second water drop on top of the first water drop. So then I end up with one big water drop. So in the first case, 1 plus 1 was equal to 2, but in the second case, 1 plus 1 is equal to 1. Because valency wise, I've got only one item after this operation. In the third case, I take one water drop, put it on the table, and I drop the second water drop on top of the first one from a great height. And then I count the number of droplets that it splits into. Let's say it's split into 22 droplets. So in this case, I end up with the same 1 plus 1, but that's equal to 22. So what exactly is going on here, and how do we figure out what 1 plus 1 really is, right? So what are the implications of all this? There does seem to be some confusion, but can we get some clarity from it? Yeah. So finally, is 1 plus 1 2 or not? The good news is, in pure mathematics, 1 plus 1 is equal to 2. Whereas in science or in applied mathematics, 1 plus 1 as an expression depends upon what we are calculating. There can be various other situations similar to the water drops which can be raised up. For example, if you take 2 units of camphor, the body heat or the heat in your palm vaporizes some of the camphor. So instead of getting two complete camphor pieces, you end up with, let's say, 1.998 pieces of camphor. So you can say that 1 plus 1 is equal to 1.998. Or you can argue that it's still 2 because the valency holds, right? So basically, there is some confusion that happens in applied mathematics. What we are probably missing is a branch of mathematics called applicable mathematics, which tells us how we can apply pure mathematics to applicable situations. So, for example, the plus operator which we are using is used as a a combination operator in pure mathematics, but in applied mathematics, it might need to change to a conservation operator. So the total volume of the water in all the three experiments is the same. So plus might need to change its definition from combination to conservation, for example. So first question for you guys, do we need a new branch of mathematics called applicable mathematics? And how do we know that since science is applicable mathematics, they've always applied mathematics the correct way? So do we need to go back and review all scientific theories to see basically if they've goofed up their mathematics, right? Do present your comments on it. A second question would be, if the purpose of mathematics is to figure out or study what's going on in the outer world, should we define our mathematics so that every mathematics is always applicable? Which means we don't have pure maths, applied maths, and applicable maths. We just have one applicable maths, which where we define maths in such a way that it can be directly applied. So that could be another option. A third question is, if 1 plus 1 was taught in is the very first thing we learned in kindergarten, and that itself seems to have so much of confusion because it well maybe the entire complexity of it wasn't understood at that point. Is there similar confusion in all the stuff that we learned after LKG? I'd like your thoughts on this. Do let me know in the comments below. So, how do we actually prove that 1 plus 1 is equal to 2? Mathematically, there is a proof called the Peano postulate. It runs into a huge number of pages, but in a gist, basically, what it says is the successor of 1 is 2, and the plus 1 operator basically means get its successor. So, 1 plus 1 is the successor of 1, therefore, 1 plus 1 has to be 2. That is the mathematical proof of 1 plus 1 equal to 2. If there's an alternate proof that I've missed out, do let me know. But this is what I could find. Yeah. So, in summary, these are the three questions that we've raised in today's video. Do provide your comments in the comments below, or your thoughts in the comments below. And as always, these are the programs which I've launched right now, working on in the future. And if you have anything specific you want to discuss with me, you have my email ID here. Thanks, guys.